We're going to look at question 1 from the practice exam, the free response question 1 from the practice exam. This was a calculator active question, and most of you got this part of the answer correct. This is A. Most of you got this correct. The first thing we notice is they tell us that g prime of x is equal to f of x. Therefore, g prime of 0 is equal to f of 0. And the reason we're finding g prime of 0 because we're writing the equation of the line tangent to the graph. Therefore, I need the slope of g of x. And the slope of g of x is the derivative. So I need to find the derivative at 0 to find the slope of 0. So just doing a quick evaluation of this, we get 4 cosine of 0 minus 0 over 2 plus the cube root of 0 squared, which cosine of 0 is 1, so that becomes 4 over 2, which is 2. That is the slope of the line. And then we're just going to use y minus y1 equals m. Now, you are guaranteed to see this on the AP exam. So please notice, this is generally what we consider the gimme questions. We're given the point 0, 1, so we have y minus 1 is equal to 2 x minus 0. And it's perfectly legal to leave it that way. Some of you solve for y, whatever. I would prefer that you leave your answer just like this and don't box it in, but leave it like that. Find the absolute maximum of g on the closed interval from 0 to 1. So most of you knew in order to find the maximum of g, we had to find where g prime is equal to 0 or where g prime of x is undefined. That is going to give us our critical points. And our critical points will lead us to determine if there is a local max or a local min. So most of you did this. Most of you set 4 cosine x minus x equal to 0 and found that that was equal to 0 at 1.252, which is outside of our range. The other thing that you had to do is determine when is this undefined. So we also had to look at the denominator and see where is this denominator, where is 2 plus the cube root of x squared equal to 0, and you would see that that never happens. So our only critical point was 1.252, and it was outside of our domain. So at this point, a lot of you just said, well, there's no max or min. But it asks for an absolute max or min. And the extreme value theorem tells us that if we have a closed interval, we are guaranteed an absolute max and an absolute min. Okay, that's what the extreme value theorem tells us. So in order to find our absolute max and absolute min, we had to use the endpoints. So I had to evaluate the function. I had to evaluate g. I had to evaluate g at 1 and g at 0. So I have to find f of 0, which we already found in the previous was 2. And then I had to evaluate f of 1. And I found, okay, I just did that wrong. Let me go back. G of 1 was, well, we know g of 0 because we found that in the previous one. G of 0 is 1. We know that from here. So now we have to find g of 1. And g of 1 is going to equal to 1 plus the integral from 0 to 1 of f of x. Okay? Because I'm told that the derivative of g of x is f of x. To find g of x, I have to integrate f of x. And since I know where f of x is at 0, I can evaluate it from 0 to 1, but I have to add where I started. Since g of 0 is 1, I had to add my starting place, and I got g is 2.146. Some of you forgot to add the 1, and I think you got 1 out of 2 points. Just by the way, this was worth 2 points. You got 1 point for finding the derivative and 1 point for finding the equation. And this one was worth 2 points as well. You got 1 point for your justification and 1 point for finding g of 1. You couldn't just say identify it as that it happens at 1. It says find the maximum value. So you actually had to find what g of 1 was. Okay? So that's where your 2 points came from that. It looks like I'm forgetting to tell you something as well. I can't remember. So if you just got 1.146, you should have gotten 1 point. The third question, find the x-coordinate of y equals h of x for values of x between -10 and 10 and justify your answer. Now we're told that f of x is the derivative of h prime of x. Okay? So h, the second derivative, is going to simply be, so since we're given the first derivative is the integral from here to here, the second derivative we have to use the fundamental theorem of calculus, and the second derivative would simply be f of x, because we would evaluate this. We're taking the derivative of this, and we have to use the fundamental theorem of calculus. So this becomes f of x. So h double prime of x is simply f of x. So now I'm going to take this function once again, and because that's my second derivative, and set it equal to 0 between -10 and 10. And I find the values to be -3.595, -2.133, and 1.25235. Now, these are our points of inflection. So you got 2 points if you found all 3. You got 1 point if you found only 2, and if you only found one of them, you didn't get any points. So you got 2 points for finding all 3. The other point came from the justification. So 3 POIs and 1 point for the justification, which we've already talked about. Most of you missed the justification because you did not say, a lot of you said because the second derivative is 0, which is incorrect. It is because the second derivative changed either from positive to negative or negative to positive. And that is the justification. Okay? I know there was something else I wanted to tell you about this one. What was our justification? So since we found that there was no local min or max in the interval, my justification went something like this. The absolute max occurs at x equals 1. The derivative is not 0 in the interval from 0 to 1. Therefore, the maximum must be at an endpoint. And then showing that you evaluated g of 0 equals 1 and g of 1 equals 2.146 would be enough justification with the answer I just wrote. Okay? Sorry I forgot to do that. And let's get to the last one. Now, what I did for the last one, I just evaluated h prime of 2. So h prime of 2 is the integral from 0 to 2 of f of x, which I got using my calculator with 7.95, and then I integrated from 0 to 3 of f of x and got 0.649, and you got 1 point for an answer. And I think I was generous. I gave you a point without, if there was no justification, if you just said h prime of 2 was greater. I think I gave you a point. I'm not sure. And the second point came from, no, I think you had to show some type of reasoning why you said h prime of 2 was greater. Otherwise, you had a 50% chance of getting it right. So 1 point for the answer, 1 point for the justification. And for the justification, I allowed you just to show your work and show that 0.795 was greater than negative 0.649. Okay? So if you have any questions on that, you can send me a remind, and I will try to answer it. And then we will also have sometime during Smart Lunch tomorrow. Also, there's a review after school tomorrow, too. So I'll see you guys tomorrow.